Right? So in the corporate form of organization, your shareholders are your owners. They're professional managers that run the firm. They're agents of owners. Okay? The owners have hired professional managers to handle their money, make wise investment decisions, and hopefully make money for them. All right? So the goal of a financial manager is to maximize the wealth of shareholders. I want to maximize the wealth of shareholders. They've been given resources. They have assets of the firm. They have cash, the owners and other folks have put into the firm, and they've got to put that to good use to generate more cash for the owners. Right? And just as a sort of sidestep here, this sounds like real capitalist and crush all the weaklings and just go make as much money as you can. Right? If you guys picked up on what was going on in Chapter 1 and Chapter 2, if you want to maximize the wealth of shareholders, you're talking about maximizing the lifetime earnings of the firm, not maximizing profits next quarter by not taking care of your workers, destroying the environment, not maintaining your machinery. If you want to maximize the lifetime earnings of your firm, you've got to take care of all of your stakeholders. Right? That includes taking care of your equipment, your people, the environment that's around you, just the community that's around you. So if you're actually doing this right, if you're maximizing the wealth of shareholders, then it does a lot of social good as well. The problem is people are greedy and sometimes they don't do it right. They maximize short-term wealth, so long-term wealth. Right, but this is talking about something a little different. Okay, so how do they do this? They need to maximize the wealth of shareholders, bless you. But how do they make business decisions? How do we make business decisions? That will increase the value of the firm. All right, well, any decision where the benefits exceed the costs increases value. All right, so over and over again, as we're using these tools, we're going to come back to this very simple value identity, where value is equal to benefits minus the costs. Right? The benefits are greater than the cost. That value number is positive. It increases the value of the firm, and it's something we want to do. What we're going to spend most of this class doing is figuring out how to quantify the benefits and costs, because it's not as obvious as it might seem at first. Especially when most of the stuff we're going to look at just involves cash flow over time. If we're in a firm, we're looking at dumping money into some sort of opportunity, whether it's a new manufacturing piece of equipment that'll make new widgets for us, or it's a new service we're going to offer or something. We're going to invest some amount of cash, and we're going to try and figure out how much cash it generates in the future and decide if it's worth it. Right? Well, it's real tempting just to say, here's the cost, here's the benefits minus the cost, good, and that's our value. But it gets a little stickier than that. To figure out why, let's look at a really simple example, just to sort of drive home the point. Let's consider a jewelry manufacturer. examples in the book you guys read. Suppose this jewelry maker has an opportunity to trade 200 ounces of silver for 10 ounces of gold. So the jewelry manufacturer is faced with this trade and has to decide, should I do this or not? Right? Well, he only works in silver, and he has plenty of silver, and someone wants to trade him silver for gold. Right? So with the information that we've gotten, what do you think? Should we make the trade?
I don't know.
I heard yes, I heard no. How do you know? Why is it not no?
It doesn't tell you how much the silver sells for, how much the gold sells for.
Not enough information to go with that. Makes me feel better if I was saying it wasn't enough gold. Okay, so what's the first question you're asking is, well, I don't know. What's silver worth? What's gold worth? Right? These are two totally different things, and we can't compare them directly. Right? Gold and silver are not the same units, right? So in your mind, you're already trying to convert them to common units. You want to convert the silver into dollars, and you want to convert the gold into dollars, and then compare. Right? So we need to convert them to common units. And for convenience, let's use dollars. Right? Since that's how we're used to trading things. Okay, so we need market prices, right? We need to know what's the silver worth and what's the gold worth. That's something we can look out and observe. The jewelry manufacturer can't say, I think my silver's worth $10,000 an ounce. Is anyone going to buy it at $10,000 an ounce? No, then it's not worth it, right? That's not what it's worth. It has a market price that people can buy and sell silver at. And it's pretty much the same for everybody. All right, so let's say, what is the market price of silver? Let's say it's $20 per ounce. And the market price for gold is $1,000 an ounce. All right, we want to put both of these in common terms. Let's start with the silver. So we're going to go silver to dollars. Right, and I'm going to draw this out in a really specific way so we can watch what the units are doing, right? So our jewelry manufacturer has 200 ounces of silver. Right, we want to convert that to dollars. We know that it's worth $20 per ounce, so we're going to multiply it by 20 of the units, bless you. Attached to that 20 are dollars per ounce of silver. Right, so when we multiply this through, what we have is 200 ounces of silver, that's the units attached to that, times $20 per ounce of silver. Well, we've got ounces in the numerator on the 200 and ounces of silver in the denominator attached to our conversion unit of $20. Those guys cancel out, right? And all we're left with is dollars. So when we take that 200 times 20 and we come up with 4,000, we're left only with the units of dollars. We've gotten rid of the ounces of silver. Right? So that conversion factor carries units for us that allow us to transfer it into just dollars. We cancel out the silver. let's go gold to dollars. Okay, he's got 10 ounces of gold. Or he has the option of getting 10 ounces of gold. We're going to multiply that times our conversion factor for gold, which is 1,000 is the number. The units attached to it are dollars per ounce of gold. Right, so the same thing happens. We've got ounces of gold in the numerator attached to the 10. That cancels out with the ounces of gold in the denominator. In our conversion unit, we're left with only dollars. And so we're left with a value on the gold of $10,000. Okay, so the silver that he has is worth $4,000. The gold that he can trade the silver for is worth $10,000. Should he make the trade? Yeah, right? We plug into that value equation. Now that everything's in common units, right? The value of this trade is the benefit, that is what he gets, the $10,000 in gold, minus the cost, what he has to give up. That's the $4,000 in silver. So the value of that trade is a positive $6,000. Right, but remember I said this guy only uses silver, right? He's not going to use gold because he has some sort of moral allergy to it, right? Gold is like Satan's metal or something. Should he still make the trade? Why? Yeah, the market price for gold is $1,000 an ounce. He can sell the gold and buy more silver with it, right? Now we can have $10,000 worth of silver, minus some transaction costs, I'm sure, from buying and selling. But he's still better off making the trade. So his personal preference for the commodity involved here doesn't matter, right? It doesn't matter. It's just the value attached to it. If it's a competitive market, then it's the value attached to it. It's all that matters. Not your personal preference. There's an awesome example in the book about winning tickets to a Def Leppard concert, but I've had to stop using it because I'm aging myself every time I get excited about Def Leppard. Okay, so this brings up a couple of points we want to keep in mind throughout this entire class. These two ideas are kind of buried in everything that we're going to do. They're implied in everything we're going to look at. The first is something we already hit on. That is the valuation principle. Valuation principle says that personal preferences don't matter. Market prices determine the value of an asset. If you're running your own business, do what you want, but you may be leaving money on the table. If you want to do it for, just principal reasons or more reasons, fine, that's your business. If you are a manager inside of a corporation, it's not your place to decide. Right? You are managing the owner's money. You go by the valuation principle. All right, the second idea is the law of one price. And the law of one price says that in competitive markets, which most markets are, identical items must have the same or very similar prices. This is something hopefully hit on in at least a micro class before you got here. But imagine the guy who wants to trade his gold for silver. He goes to the silver jewelry manufacturer and says, "Hey, I want to trade my 10 ounce gold for 2 ounces of silver." And the guy says, "Yeah, fine, but I'm going to charge you $50 an ounce for my silver." That trade. Would the guy go ahead and make the trade the gold for silver? No, he's going to go out on the market and do it somewhere else, right? Because he can get it cheaper. The market price for silver is $20 per ounce. Then he's not going to make the worst trade, right? And what allows these prices to stay within the ballpark of each other, right? There are transactions costs when you buy and sell something, especially if you go to a market or a middleman. They're going to take a little bit off the top, so the price is going to be very nearly the same. What keeps these prices similar is an idea of arbitrage.
The word arbitrage sounds very fancy, but it's actually a very simple idea. It's really just taking advantage of differences in price on essentially the same thing to make risk-free profit. So let's just think about it a little bit. Let's say in one part of town, there's some type of a market. Let's say it's a market for apples. And let's say in that market, apples sell for, let's make up some price. Let's say that apples in that market sell for $1 an apple. $1 per apple. And let's say in another part of town, you have another market. Another market. It's literally a fruit market. And in that other part of town, apples sell for $1.50 an apple. $1.50 an apple. So how could you take advantage, and we're going to assume that these apples are completely identical apples. How could you take advantage in this price difference on these identical things to make a risk-free profit? Well, ideally, you would want to sell apples in the more expensive market where you could get $1.50 per apple, and you would want to buy apples in the less expensive market where you can get them for $1 per apple. And that's exactly what you would do. You would go to this market over here, you would buy apples. Let's say you buy 10 apples for $10. And then you would go, maybe, ride your bicycle a couple of blocks to that other market over there. And you would sell your 10 apples. So this is buy 10 apples for $10. And then you would sell those 10 apples. You would sell those 10 apples for $15. $15. And so you would make an immediate risk-free profit of $5. You're buying for 10, selling at 5. And you can just keep doing that over and over again. And on every trip, as many apples as your bicycle can carry, you'll just continue to make money. And so this is what arbitrage is. And just to imagine a side effect, if someone did this enough, then what it would do is it would increase the supply of apples here. So the supply would increase in this market. And on this market, the demand would increase, because there's someone who just keeps buying from this market and selling into that market. So what's eventually going to happen when demand increases, the price will go up in this market. The price will go up in this market. And when the supply increases in this market, the price will go down. So in theory, the more you do this, the more that you're going to make these prices come closer to each other. And eventually you won't be able to make any profit at all. But while there's this discrepancy, you have an opportunity for arbitrage.
Thank you, Colin. You guys use Khan Academy and other classes, or you use it yourself to study at all, to go look stuff up? Ever heard of Khan Academy? Oh, dude, it is awesome. If you're ever struggling with anything, in particular a math or finance class, yeah, Khan Academy. Hold up. KHAN. KhanAcademy.org. Right, this site is awesome if you've never been there. It's funded by a lot of private investors, and they've got some really fantastic teachers to get on there and just do lessons. Started out as math lessons for like someone's nephew or something like that. And it's just taken off. They've gotten tons of money to make more videos on almost anything you can imagine now. But there's a lot of great finance and math resources if you're ever stuck on something. It's worth getting on Khan Academy and searching for it. There's probably a really good video. Okay, but arbitrage makes sense. Why prices tend to level out in competitive markets, right? Be pretty close. You know, obviously, there's in the Apple example, that's a good one to point out the transactions cost idea. It's costing you your time to go back and forth with your bike, right? Apple prices don't have to be equal. It doesn't have to be $1.25 each one for it to not be worth it for you anymore. Maybe it's $1.20 in one market, $1.25 in another market, and you're only making like 10, 20 cents every time you do it. Well, now it's not worth it anymore. So the prices may not be exactly the same in all markets, but they're going to be pretty doggone close in these competitive markets. Okay. So why the heck are we talking about all this, right? How do we use this? How does this apply to finance? What we're going to figure out, bless you, and I'm going to go ahead and plant the seed right now, is that money actually has a market price too. Interest rates are the competitive market price for dollars. So interest rates are the competitive market price for dollars. I'm going to plant that seed and let it marinate while we sort of develop this idea. Okay, finally we're getting there. The time value of money. Time value of money means that in general, $1 today is worth more than $1 in the future. And you guys are all familiar with this. You actually do this mental calculus in your head all the time, right? But just to prove the point, let's suppose I'm going to offer you guys an investment opportunity this summer class. Okay? And this is hypothetical, but we're not actually going to do this. But just imagine we did. Let's suppose I offer you guys the following opportunity. Okay? You guys each have the opportunity to pay me $10 right now at the beginning of class. And when this class is over at the end of the term, you don't have to pass. There's no stipulation attached to it. When the class is over, I'm going to give you $10 back. Right? Does anyone want to make that investment with the Bank of Stelk? No takers? Why not?
Because there's got to be a catch.
No benefit.
But no benefit. In fact, there's a cost, right? You're going to tie your cash up for 2 months. You could go buy beer, in fact, a decent 6-pack of beer, or maybe beer and pizza with it right after class and drown out everything you heard, right? So there's opportunity cost associated with that $10. I need to compensate you for that if I want to get your money, right? Okay, so let's suppose you pay me $10 at the beginning of class. I will pay you $15 at the end of class, at the end of the summer term. Any takers on that? 50% return in 2 months. That's helpful. Okay. That's a massive return in percentage terms, but it's only $5, right? So then you gotta wonder, is it worth me giving up that really nice 6-pack of beer after class?
6-pack of bad beer.
Okay, what about you guys pay me $10 today? I'll pay you $100 at the end of class. Right? Anybody taking that? Okay, so there is some interest rate that exists that I can induce you to trade dollars today. You'll give up your $10 today, and I will pay you dollars tomorrow. Right? So there is some rate that's making that switch flip in your brain and say, yeah, that's worth it. I'll give up my cash today for that. Right? So you know this. $1 today is worth more than $1 in the future. If it's just straight dollars, you'll keep them today, right? $10 now for $10 2 months from now, keep your $10 now. It's worth more. Right? When you start upping the value on the back end, you start having to make that judgment, right? Is it worth it for me to give up my dollars today? Okay, so let's figure out a way to actually operationalize this. How do we quantify it and start dumping it into this value equation? Right? Let's suppose your bank offers 10% interest per year on all savings deposits. %, obviously unrealistic, but we're picking a number that's easy to just sort of wrap our heads around. So we don't have to bust out the calculators just yet. All right, if you deposit $1 today, how much will you have in 1 year? $1.10, right? Yeah. How'd you figure that out? How'd you get to $1.10? It's 10% of $1, and then you got to add that 10% back to it to figure out what you get, right? Okay, so I'm going to draw out a timeline and introduce this idea. All right, today is time period 0. We're going to do this a whole lot. We're going to spend some time breaking it down, but we'll at least look at it here. All right, time period 0 on this timeline is today. Time period 1 is in 1 year. You deposit $1 today. You're going to let it collect interest for 1 year. And I'm going to call the interest rate R. So you will end up with $1.10. Okay, and I'm starting incredibly simple because I want to show you a math shortcut we're going to use over and over and over again before we've got more stuff we're trying to deal with at the same time. All right, so how did you figure out that $1.10? The first thing you figured out was the interest. All right, you took that $1 and you multiplied it by 10 cents, or 10%, I'm sorry, 0.10. Right, that's 10% expressed as a decimal. Okay, and so you figured out the amount of interest was 10 cents. and then you added that interest to the original deposit of $1, right? So your original deposit of $1 plus your 10% interest, you ended up with a total of $1.10. Okay, let's write all that as one step. All right, so what we did first was took our $1 times, I'm going to substitute now and say R, so times our interest rate. And that gave us the amount of interest, that was step one. And then we added that dollar times the amount of interest. All right, so if we're actually writing this as one step, let's not run them all together, sorry. There we go. So we calculated the amount of interest and added to that the $1. Okay, let's factor out the original $1 deposit. All right, so I'm going to pull that $1 out, and I'm going to multiply that times what's left. When I factor out a 1 right there, I'm left with a 1. I factor out a 1 right here, I'm left with the R. So I'm left with 1 times 1 plus R. So if I plug my actual number, the interest rate back in, what I end up with is $1 times 1 plus 0.1. Right, and if you multiply all that out, you're going to end up with the same dollar. So instead of going through that two-step process where you calculate the amount of interest and then add that to the original principal, we're going to end up doing it all in one step, just like this. Most of the time. That difference between money in the future, right? In this example, that was $1.10. And money today, in this example, that was $1. Is the time value of money. And that interest you pick up. All right, so what we figure out is the interest rate converts cash across time. And it can go either forwards or backwards. And by depositing money, let's say in an investment, you convert dollars today into dollars in the future. Alright, so interest rates can move forward by you earning interest. The one we're all, unfortunately, a little more familiar with in college is going backwards. By borrowing money, we're doing the same thing in reverse. We convert money in the future right, where that money in the future are our promised loan payments. Into money today. Out of the loan. Right, and as we've already said, the interest rate is the competitive price of money. Right, and how is it competitive? Well, lenders, as I'm sure you're well aware by all the junk mail you get, credit card offers, and investment brokers compete for your dollars. Okay? The lender wants to be competitive. They either need to lend to you when no one else will, all right, or they need to charge you a competitive interest rate. You'll pick the lowest interest rate available to you. Right? Investment brokers, same deal. If they want your money today instead of making you pay them later, then they need to offer you the most attractive returns possible, right? Or offer you investments that you can't get anywhere else. But the interest rates are a competitive market price, both for you and I as individuals and in the finance and corporate settings as well. Waiting for a couple of folks to jump right to the next page. No rush. You guys take your time.
Investment what?
Investment brokers. Well, that's what it's supposed to say. It says screw. My handwriting's bad enough, y'all. The screen is not either. All right, let's actually apply this to an honest to goodness example, all right? Let's suppose we've got a business. And it is offered the following investment. Pay $100,000 today. In receive $105,000 in 1 year. All right, now decide, should we make the investment or not? Right, should we trade $100,000 today to receive $105,000 in 1 year? What do you think? Oh, you guys are just making me feel all lovely inside. Yes. What's the interest rate? Should be the first question, right? This is dollars today and dollars in 1 year, right? We just saw that we need to be really careful here, right? We need to worry about the rate of interest that moves dollars across time, right? And then someone else, you offered up on the front row, who said, what is the interest rate? Well, it's 5%. How did you know it's 5%?
$5,000 is 5%.
Okay, so we can already look at this investment and just say, oh, that's a 5% rate of return, right? So that allows us to ask another question. What's our next best alternative? Right? Can I do better than 5% somewhere else? All right, so let's suppose we have another piece of information. The business banks the same bank you do. So they're just going to earn 10% on all bank deposits. Okay, what do you think now? The investment of $100,000 for $105,000 still looking okay? Why not? Because you guys are just shaking your head no.
Deposit it and make 10% instead of 5%.
You can deposit and make 10% instead of the 5% on this investment, right? All right, so these are nice, simple, round numbers. We can kind of look at it by inspection and go, no, there's a better idea here. But let's come up with a formal process to do this so when things get more complicated, we have a tool to throw at it. Okay, so we're going to go back to this value equation where value is equal to the benefits minus the costs, but we need to make sure the benefits and the costs are in the same units. And this is where things get really confusing when we're talking about cash. $100,000 today and $105,000 in 1 year looks like the same units. They both have a dollar symbol in front of them, right? But there's actually a time value component attached to those that we normally just lop off. We don't worry about. Okay? That's going to change after this class. You guys are like me and words are more confusing than pictures. Pictures help. Stuck in the 6th grade somewhere. Let's draw a timeline of what's actually happening here. All right, so we've got today, which is time period 0. We have 1 year from now, which I'm going to use a 1 for. Okay, and so today, we have the opportunity to give up 1,000, or 100,000, I'm sorry. But I'm going to be really careful when I write this. It's $100,000 today. Right? There's a time value attached to that number. It's not just $100,000, it's $100,000 today. Right? What I'm promised to receive is $105,000 in 1 year. Right? There's a time value attached. The number is 105,000, but the time value attached to that is 1 year. This is exactly the same thing as 200 ounces of silver and 10 ounces of gold. They're totally different units, and we can't compare them directly. Okay, so let's label these guys. This $100,000 today, in terms of this investment, that is the cost. Right? That's what I have to give up today if I'm going to buy into this investment. The $105,000 in 1 year, that's my benefit. That's what I get if I were to give up that $100,000. And what I want to do is be able to take the benefits minus the cost, but I have to convert them to common units. All right, so what I want to do, I'm going to start by converting the cost into the same units as the benefits. Okay, so we're going to move forward first. We're going to start by converting costs into the same units as the benefits. I.e., that is dollars in 1 year. Okay, and we've actually already looked at the mechanism we're going to use to do this. We're going to use what is called the interest rate factor. And the interest rate factor is 1 plus R. Where R is the interest rate. And the interest rate factor carries units with it. Just like our conversion factor when we're going from ounces of silver into dollars, carry units of dollars per ounce of silver, this conversion factor does the exact same thing. That 1 plus R carries the units of dollars in 1 year over dollars today. Okay, so here's how we're going to do it. We're going to take that 100,000, remember we're converting the cost into dollars in 1 year. That 100,000 has units of dollars today. We're going to multiply it times our conversion factor, where they can earn 10% on their deposits, so that's 1 plus 0.10. All right, our interest rate is 10%. That conversion factor carries units of dollars in 1 year over dollars today. So when I go to multiply these things, the same thing is going to happen here that did with our ounces of silver going into dollars. Dollars today in the numerator cancel out with dollars today in the denominator. And I am left with 100,000 times 1.1, or $110,000 in 1 year. Okay, so let's go plug this into our timeline. We're going to go back up here and drop this guy in. We've now taken this $100,000 of cost and converted it into dollars in 1 year. Right, I put my cost out there, and now we can compare them directly. So they're both in dollars in 1 year. The benefit of this thing is $105,000. The cost, what I give up, is $110,000. Right? Because I could have put that money in the bank and earned 10%. So by putting it in this investment instead, I gave that up. Right? So this investment is actually costing me $5,000. Right, so now that we've got everything in the common units, we can actually dump it into this value equation where the benefits and the costs are all in the same unit. The benefits are $105,000. The costs are $110,000. All right, so the value is a negative $5,000. Right, but I'm being a little bit lazy saying $5,000. What are the full units attached to that number? $5,000 in 1 year, right? In 1 year. Someone tell you guys this class was hard? Yeah, want to go back to natural about now? No. Oh, I forget what I made you guys do before this class.
It doesn't get any harder than this. Right.
Okay. Let's try going back the other way. You guys okay with what's happening here? This rocket surgery? No, right? Not too bad. Not too bad. Okay. Let's run it the other way. Okay, let's review this timeline. You don't have to do this in your notes, of course. Just be clear. Use a new page. So 0, 1, we've got our $100,000 today. That's our cost. Our $105,000 in 1 year. That's our benefit. All right, so we looked at running the cost out to future dollars, right? Dollars in 1 year. We can do this just as well by taking our benefit and converting it into dollars today. Okay, so I'm moving backwards in time. I said originally the interest rate either moves forwards by converting dollars today to dollars in the future, or you can convert dollars in the future into dollars today. Okay, to do this, let's say first, or we can convert the benefit into dollars today. Okay, to do this, we're going to use the discount factor. Okay, the discount factor is just the inverse of the interest rate factor. Just flip it and put one on top of it, as so it looks like this. When we flip it on its head, the units also flip. So now we've got dollars today over dollars in. Okay, so let's plug this guy in and use it. Let's take the $105,000, that's dollars in 1 year. I'm going to multiply that by my discount factor, which is 1 over 1 plus 0.1. attached to that thing are dollars today over dollars in 1 year. Okay, and so what happens is the dollars in 1 year cancel out. I'm left with just dollars today. All right, and I'll simplify this one a little bit. So we get 105,000 divided by 1, type it all in, 1.1. Right, so I just added the 1 to the 0.1. That's going to leave me with the units of dollars today. Okay, if you dump that into a calculator, or you're just really good at doing math in your head, you should come up with something close to $95,454.55 today. So if we plug that back into our timeline, that's 95,454.55. That's dollars today, and that is our benefit. Alright, so if we drop these guys into our value equation, the benefits minus the costs, the benefits in this case are the 95,454.55 minus the costs of $100,000, and we get a negative 4,545. Today. So still a value decrease in the investment. So it doesn't matter which way you go. When you're working time value of money problems, you can move dollars all into the future, you can move them all into the past, you can put them somewhere in the middle, you've got multiple years. As long as you put them all in the same terms, you're fine. Good to go. Right? You just have to have them in the same units to be able to compare them directly. As a matter of fact, just to sort of drive the point home, when we converted everything to, in the first one, we converted everything to future dollars, we ended up with 5,000, right? And when we just did this, we ended up with 4,000. 4, 5, both of those are negative. And what I'm going to tell you is those two are actually the exact same number. They're exactly the same. What confuses us is when we forget to consider the full units. This is dollars in 1 year. This is dollars today. In fact, if we convert them to the same units, if I take this negative $4,545.45 and I multiply that times my conversion factor, I'm going to get something pretty doggone close to 5,000. I'll only be off by whatever rounding error I introduce. They are exactly the same number, just with different units. You guys okay with the mechanics of this? Multiplying by the interest rate factor, multiplying by the discount factor, or equivalently say dividing by the interest rate factor? Okay, all right. Well, this idea of converting cash across time boils down into this very simple formula. And this formula drives everything in finance. Right? It moves values through time using the interest rate factor and allows us to be in equivalent units no matter what time period we're looking at. And this is the bedrock of all finance right here. Right? This underlies everything. And I said before, from your car note to your mortgage payments to those complicated derivatives that are out there. This time value relationship drives it all. Okay. All right, what does this stuff stand for? FV stands for future value. PV is present value. 1 is 1. But sometimes finance those can be tricky, so I'll get later. R is the interest rate. And M is the number of periods. Since we only moved one period in the example we just looked at, we sort of forgot about M, just left it off because it's 1 anyway. But this is exactly the formula that we used, right? Where when we were converting from, when we went from dollars today into dollars in 1 year, this is the formula we were using, right? We multiplied times the interest factor, which is right here. We converted those dollars today, the present value, into dollars in 1 year, into future value. Exactly what we're using. If we rearrange this thing and solve for present value, now we're using the discount factor. So it's the exact same relationship. It's just solved for a different variable. And if you can imagine, there's what, 4 variables in there? There's present value, future value, interest rate, and number of periods. We're going to solve for all 4 quite a bit before we're out of here. There's 3 rules we need to follow when we're working time value money problems. So I want to write down those 3 rules so you've got them in your notes, and then hopefully there'll be more recall there. You've heard my goofy voice saying it, your hand wrote it down, right, and your eyeballs saw it going down on the page, right? So we'll remember to follow these 3 rules. We'll have all those keys for them. If you follow these 3 rules and all the time value problems, you're good, right? You will be golden. Doesn't matter how complicated it gets. So rules for working TVM, time value of money problems. 1, it's only possible to compare or combine values at the same point in time. It's only possible to compare or combine values at the same point in time. To solve that real basic example, if you were to just look at $100,000 versus $105,000 without considering the interest rate as an conversion factor, you'd make a poor decision, right? You would trade the 100,000 to 105 to make $5,000, when in reality you're getting up $5,000, right? So you want to move those values into the same point in time. All right, second one. Actually, these really just flow from the first one. They're kind of subset. Calculated cash flow's future value, you compound it. Compound it using the interest rate factor. That 1 plus 1. Alright, the final rule to calculate a cash flow's value at an earlier point in time. Discount it. The discount factor. That is just 1 over the interest rate factor. Once we've got those, I just want to look at a handful of slides that look at what happens if we start compounding interest over more than one period. Something pretty cool happens. And then I'm going to pick out a couple of homework problems to work. You guys are not going to have a problem in chapter 3 at all, but you just need to spend some time digging in. But we'll pick out a couple of them just to work together before you guys get thrown into the chapter 3. We'll be through chapter 4. Okay, let's look at, just have an idea of what happens as we compound over more than one period, right? I'm pulling slides from the book, so I think the examples are in the text as well. But let's say when we're compounding, we start with $1,000 today. We've got a bank that pays 10% interest. What happens as we move into more than one period? All right, so we start out with $1,000. We start out with $1,000 at time period 0. Over 1 year, it earns 10% interest, right? So we multiply by that interest rate factor of 1.1. That turns into $1,100, right? So in dollar terms, we earn $100 worth of interest over that first year, right? The $1,000 times 10% is $100 a year in interest, right? But look at the second period, right? So at the end of the first year, we're left with $1,100. We multiply that again by our interest rate factor to move it forward 1 more year. And we end up with $1,210. And so from $1,100 to $1,210, now we earned $110. We didn't earn $100 interest, we earned $110. What happened there? Why did we earn more interest?
More money.
Yeah, we started with a higher amount, right? Instead of starting with $1,000, we're starting with $1,100. $100 of that was interest, right? And that interest, that $100, also earns 10%. Well, 10% of 100 is $10. So that extra $10 that we earned in a time period 2 is interest on interest, right? We call that compound interest because you're getting both the simple interest from the original principal plus the interest on interest, right? Interest on interest is a cool. It is a cool thing. All right, if we were to multiply that over several time periods, we end up with the equation that we were looking at. But check out this picture. All right, let's suppose you take that $1,000 that you deposit today and just let it sit there for 20 years, right? Earning 3% interest. And this chart breaks down the money that you're going to earn into 3 separate categories. The red bars on the bottom, because they look red in my eyes, that's the original principal. That's the original $1,000 that you're getting right there. The green bars that go up in a linear fashion, a straight line right there, they go up, in fact, $100 every single year. That's your interest on the original $1,000, right? So that goes up $100 every single year. Like every year you get another $100 that piles on into your bank account. The blue lines on top, this is your interest on interest that you're earning, right? That first year that we saw, there wasn't any, right? It was just simple interest, $100. That next year, the interest on interest was only $10, right? 10% of the 100 that were on there. But it starts creeping up, right? In fact, when you get to some point, somewhere around year 15, year 16, if you're looking at the breakdown of the total value in your account, the bulk of it is interest on interest. Most of your money is coming from interest you earn on interest, right? In fact, you're ending up with just something south of $7,000 from an original investment of $1,000, right? So you've increased your wealth over 7 times, right? Just letting it sit there and earn interest. Now, $1,000 isn't much, right? But imagine any amount of money that you can increase over 7-fold, right? Over a period of years. You guys mostly in your 20s or so, right? For the most part, you're probably not going to retire. We're all screwed. We're going to work until like we're in our 70s because medical technology is going to keep us younger for longer, right? So I mean, you guys have got 40, 50 years of work. Interest on interest working for you for 40 retirement account. If you want to be a millionaire when you retire, it ain't gonna take much if you start now, right? Because this effective interest on interest is incredibly powerful.
But what's the inflation rate?
That's a fair question. So you would, that's actually built into the interest rate inside of there. We go to make this calculation. Say I want on a real rate of 10%. I think inflation is going to be 3% over that period. So you say 13%. And we mentioned you guys, as long as you've been adults, we've been an incredibly low interest rate environment. But you guys know what the average return on the stock market has been over the existence of the stock market? How long we have data for? 10 to 12% a year, even including a huge 10-year recession. Right? So, for example, someone like me who's looking at, I'm going to be a professor, I can easily work in my 60s or 70s, right? So I've got 30 years to make retirement savings. My retirement portfolio is 100% in the stock market, right? So I'm earning 10 to 12%, and I'm looking at doing that over the next 20, 30 years. It's huge, guys. As long as you get started young enough, it's amazing. Assuming dollars are worth anything by the time you're retired, that's a bit of a risk. But no getting away from that. We're all exposed to it. All right, I talked about timelines. I'm going to hammer these over and over and over again. You saw me drawing them, kind of labeling things out. The problems in chapters 3 and 4 are really, really simple and straightforward. I wanted you to get in the habit of drawing timelines, even for these really simple problems, now. There's a little bit involved sketching them, and I want it to be second nature for you by the time we get into chapter 5. Because then cash flows start getting really funky, and you've got to draw your timeline, or you're never going to get the timing right. As we start looking at paying off a mortgage on payment number like 126, right? You've got to figure out the balance of the mortgage at that time and figure out what's going to take to pay off in the next month. It's a mess. It's a nightmare. Unless you do these timelines, then those Alright, so there's a method to how we construct these things. You saw me labeling the dates on top. That's the typical way to do it, and we usually mark them in time periods instead of using dates like, June 7th, 2016 as today. We use time period 0 as today, and we'll use 1 for the end of that first period. It could be years, it could be months, it could be weeks, it could be anything, but we mark the number of periods, right? And from 0 to 1, in this case we're looking at years, year 1 is happening over this period, right? So that 1, when we see it on the timeline, represents the end of year 1. And it's really tempting when we start doing this to see the 1 and say, oh, that's the beginning of year 1. That's the end of year 1. Let me put this on. All right, so year 0 today, right now, starts the beginning of year 1. The 1 tick mark marks the end of year 1 and the beginning of year 2, right? And so in between the tick marks of 1 and 2, year 2 is happening. And this number 2 here marks the end of year 2. And we put the cash flows on the bottom of the timeline typically, and we use positives and negatives to keep track of the direction of those cash flows. So on this timeline, what's happening is we have a 0 cash flow today, nothing's happening. At the end of year 1, or equivalently beginning of year 2, we have a $10,000 cash inflow, and that's followed by an additional $10,000 cash inflow 2 years from today. And if we look at the next timeline, it just shows a negative in there. So with this timeline, same setup, 2-year time span, but now we've got a $10,000 cash outflow today. It's a negative. It means it was cash out of our pocket, followed by 2 cash inflows of $6,000. One in year 1, one in year 2. Okay, you guys want to play with some of these? Haven't had enough fun for today yet. Alright, let's go to, I haven't done the review chapter, so we'll let you know. Go to some answer. Yeah, this will make us do all the cool questions. Okay, so let's look at number 7 from the chapter 3 homework. We'll just work a blank one. So I'm going to use the numbers in my homework problem, totally different from the numbers in your homework problem because they're all random, and then we'll look at the example and see if they're all the same. All right, so a friend asked to borrow $50 from you, and in return will pay $53 in 1 year. Your bank is offering 5.5% interest rate on deposits and loans, and we have 3 questions. A, how much would you have in 1 year if you deposited 50 instead? B, how much could you borrow today if you pay the bank $53 in 1 year? C, should you loan the money to your friend or deposit it in the bank? Not as like an oral question, but as in a time value question. Okay, so let's map this stuff out. Put everything down. A friend wants to borrow 50, we'll pay you 53. What? So. And that's code 3-11. Alright, so a friend wants to borrow 50, he'll repay 53 in 1 year. How would it be for this year? Bank point pays 5.5% interest. Alright, and question A, how much would you have in 1 year if you deposited 50 instead? Alright. So even though this problem is incredibly simple and I don't necessarily have to do it, I'm going to get in the habit of drawing my timeline now while it's easy. So I'm not having to figure out timelines and really complicated problems in chapter 5. Alright, so I'm going to deposit $50 in the bank today. I'm going to let it sit for 1 year, earning 5.5% interest. And I want to know how much money am I going to end up with in 1 year. I'm going to use that future value equation. Future value equals the present value times 1 plus r to the n. So for this problem, I'm starting out with the 50 bucks. I'm going to earn 1.055, and I'm going to earn it for 1 year. So 50 times 1.055 equals 52 bucks. Alright, so if I deposited my cash instead, I would end up with $52.75. So I could earn $52.75 from the bank, or I could earn $53 from my friend. Right? Assuming I actually trust my friend, I earn an extra quarter loan to my friend. Alright, so I actually packed a fair amount into plugging into that form. You guys okay with where I got the 1.855 from? Okay.
How'd you get it?
Yeah. So let me actually write it out a little bit more granular. So I took the $50, it's times 1 plus r, right? So 1 plus 0.055, where my interest rate is 5.5%. It's right to the desk.
Okay.
Yeah. So that turns into 1.85. Is the addition before multiplication. Okay, what did part B ask us? If we borrowed 50. Yeah, how much could you borrow today if you pay the bank $53 in 1 year? Alright, so this kind of turns it on its head. What's happening now is we're going to repay $53 in 1 year, and it wants to know how much could we borrow today. Right, so we promised to pay the bank $53 in 1 year. How much can we receive today, assuming we have to pay a 5.5% interest rate? Right, so for this one, we're going to use the present value version of that equation, where it's the future value divided by 1 plus r at the end. So the 53 divided by 1.055, it's raised to 1, so pretend like it's not there. Before I even type that in, the answer I get, is it going to be greater or larger than $53? Smaller, yeah, why smaller?
Because it's the
present value, so I should expect it to shrink, and just mechanically, I'm dividing by something larger than 1. Right? So if you mess up when you're first doing this and do something like divide by the interest rate, it's going to get a big number, right? So just keep in mind that it should be shrinking as you move backwards in time. And what the problem has actually done here is given us 2 ways to compare the offer from our friend. The first is we took the $50, we converted it into dollars a year from now, and the bank looked like a less attractive offer. The other thing that we did was we took the $53 and converted it into dollars today, right? Where we only have to give up $50 for the loan for our friend, but if we wanted to earn the same $53 from the bank, we'd have to give up $50 and 23.237. That's right, $50.24. So we'd have to give up more money to the bank in order to get that same $53 payoff. Right? But both are doing the same thing. One's comparing future value, one's comparing present value, and we come to the same conclusion. The loan to our friend is a better deal. Yeah, assuming we'll actually pay it back. So if we deposit the money in our bank, that's it. 75. Rounds to near a cent, so 50.24. From a financial perspective, you should lend money to your friend as it will result in more money for you at the end of the year. Any questions on that? You guys okay? Right. Good. Oh, I'm sorry. Let me go back to number 7 real quick and look up. I haven't talked about this, and if you guys haven't figured it out yet, it's worth mentioning. If you get in one of these problems and you're not sure how to work it, right, which is likely to happen, heck, I have to do it still on some of these that don't work very often. I look at them. What's that? All right, there are a couple of tips available on most of these. The first one is this 1, 2, 3. That's to help me solve this. And you guys may have figured this out working chapter 2 stuff. If you click on that, it's going to open up your exact problem and kind of give you hints to work through it. Right? But once you get the right answer, it resets your problem and makes you work again with fresh numbers. It's incredibly frustrating. Right? What I found is a little more efficient way to go after it is the purple light bulb here. Yep. Ignorant survival guidance in there. The purple light bulb is view an example. This one's so much more helpful, at least in my experience. This pops open the same problem in a new window, but with different numbers. And the numbers inside the example problem are the same for everybody. The numbers my homework pulls up is the same yours pulls up. Everybody has the same numbers in the example problem. Okay? What's even cooler is you can leave up the example problem, follow along with it, and work your problem, right? And it's not going to reset it on you. Okay? So this is a really cool tool for learning to work the problems. Obviously, this is a beginning step. You can learn to work problems without it, but it's a great way to get started. Good stuff. All right, it'll walk you through using the same formulas we did, just with different numbers. Other stuff that's available on some of them. There's e-text pages. If you bought an access code that has a copy of the e-text with it, you click on that, it's going to kick you directly to the section of the e-text that's talking about this particular concept. All right, so that can be helpful. I'm probably going to go in and disable this because I'd rather keep you guys using the discussion board, and I spent like 6 hours yesterday going through emails and I haven't responded to all of them yet. The Ask My Instructor button will send your problem directly to me, but if you guys get stuck on the homework problems, I want you to post the question on the discussion board in my Finance Lab instead of emailing me. right? I'm still going to answer them on the discussion board. It's not for me to dodge the word. But what I want to do is have the question and answer posted on the discussion board so that when someone else goes to ask the same question, the answer is already there. It speeds up your study time, right? Sometimes you're going to be asking questions, most of the time you're going to be getting from the answers. So it helps with everything for those. And nothing's been posted on the discussion board yet, so you guys know where it is. Alright, so let me point that out real quick. When you log into My Finance Lab and you go to Communication Tools on the left navigation structure, all you'll see there is Discussion Board. Right? So you log in, Communication Tools, and Discussion Board, and you've got a section here to ask questions. It tells you what format to put the questions in so they're easier to find later on. And you've got an example of a question someone asked and I answered on the discussion board, so you can follow that format. Now, you guys are sharing this discussion board with the online class, and you should ask them a bunch of questions. Right, so there should be, when we're a few weeks in, there should be a pretty good repository of stuff to look at. Okay. Let's Alright, let's look at one of these multiple time periods just because we haven't done that yet, and then I'll cut you guys loose. If you have specific stuff you want to look at, I'll be happy to stick around and do that, but listening to anyone for 2 hours is more than any sane person can bear. Cut you guys loose. Okay, so let's look at number 10 from chapter 3. That's problem code 3-15. I should mention this too. I'm giving up a class for you guys. Normally I would work through chapter 2 together just so I can show you how I use the software. So there's a bunch of stuff I'm thinking about that you would normally have. Okay, the problem codes, the numbers inside of here in your homework, those will change on different assignments, right? The number of the problem will be different on your quiz, it'll be different on your test, and it'll always change, right? But this problem code, this P3-15, that code is tied to this questions now, right? So if you work your quiz and you mess that problem up, you want to go back and find it in the homework to review it, you look at the problem code and you go back and find it that way, right? So you know which one it is. Right, the problem codes are stationary, the problem numbers go all over the place. All right, so number 10, you're considering a savings bond that will pay $100 in 9 years. If the interest rate is 1.6%, what should you pay for the bond? Right, so let's map this guy out. Alright, so the savings bond is going to pay us $100 in 9 years. The question is, how much should we be willing to pay for it today? Right, if our interest rate is 1.6%, that's the best we can do anywhere else with similar risk. The question is, how much should we be willing to give up today in order to buy that $100 savings bond? So what it's asking is just what is the present value of that $100, right? We're going to use the present value formula, the future value divided by 1 plus RPN. Right, and this is the first one we've looked at with multiple time periods. We're just got to plug in that in. So 100 over 1.016. Converted that percentage to a decimal and added it to the 1. Okay, and n in this case is 9. Right, that $100 is a cash flow that's happening 9 periods from now. And n is the number of periods that the discounting takes place over. you guys are already using the BA2 Plus, I'll show you how to work it on here. If you're using a scientific calculator, rock on is perfectly fine. When you go to take a test, you can bring in multiple calculators. Alright, so if you're not comfortable with the BA2 Plus yet, or you're using the online financial calculator, you can bring your scientific calculator into the testing center. Okay, so here's how I would work it on this thing. I would say, actually, is anyone already using the BA2 Plus? Okay, let's go through something really quick before you do anything else. And we'll go through this again next Tuesday, a week from today. Let's set your calculator to follow algebraic rules of operation. If you haven't set it up yet. To do that, hit second, which is on the second row all the way to the left. And format, which is the decimal on the bottom of the center. Okay, it should pull up DEC equals something. If you haven't messed with it before, say DEC equals 2. That's the number of decimal places your calculator is set to. I like mine set to 4, so I press 4 and enter. And there's no magic reason for 4, it's just a good balance of places on the left and places on the right of the decimal for me. I wouldn't go any lower than 4. You do a lot of percentages of decimals. This does not affect the precision of your calculator. It's exactly as precise, whatever you have it set to, but this just is how many it displays to you. All right, DEC equals, you guys still in that menu? We're going to hit the down arrow key 1, 2, 3, 4 times. Calculator should say CHN, or keep going down until you see CHN. I forget what that stands for, because I've read the manual in over a decade now. But it is not algebraic rules of operations. So if you're in a long string of multiplication, addition, subtraction, we'll screw it all up. So we want to change that to algebraic rules. The way we do that is by hitting second and set. Set is the enter key on the top row. Second and set. And second set will toggle it back and forth between CHN and AOS. AOS is what you want. That sets it for algebraic rules of operations. Going good? That's you can. I'll show you a video on my client's lab while we do this as well. Okay, now that we've set the follow algebraic rules of operations, we can enter this thing all in one piece. It'll do it for us. All right, so I'm just going to enter 100 divided by 1.016, and do not hit equals yet. While that 1.016 is on the display, press the Y to the X key, right above the 9. And that's going to raise this number to the power I put in next. Right, I want to raise that to 9. Press 9. Now I can press equals, and it'll work it all in the correct order for me. So 86.69. Should have been going down. That looks reasonable. All right. Okay, so that's how you do it with multiple time periods. You just put the number of periods in the end, but it's in the present value on your operations. If you want to set your calculator up, I'm not going to show you how to use them, the finance stuff, until we get to chapter 5. But if you're using your BA2 Plus for other stuff, you want to walk through that setup. Alright, that setup for the VA2 Plus, when you log into My Finance Lab, click Document Sharing. You've got several folders inside of here with different options inside them. The TI VA2 Plus Setup folder, when you click that, below it you're going to get a list of both written instructions, your owner's manual, and a video walking through the VA2 Plus setup inside of there. So before you start using that thing, definitely set it up because it will mess you all up again. Okay, that's all I want to look at. Don't forget your Chapter 3 homework and quiz is due tomorrow, so you guys get in, spend some time with it. It'll be one of the easier chapters in the work. Accelerate pretty quickly from here. If you've got any questions, remember to use the discussion board.